Myself Ritu Randev, PGT Computer Science, Kendriya Vidyalaya, Noida. Today I am going to discuss about flow of controls. In part 1, the conditional statements are considered here. The flow of control means the execution of the program. How a program executes. Generally, a program executes from start point to the end point, whereas some programs do not execute in order. But as per the requirement, the execution order of the program may vary or change. It is possible also to execute a program repeatedly. Till now, we have seen that a program executes step by step. In the examples of finding the simple interest, how to add the numbers, how to find the average of the numbers, these all kind of programs come under sequential programming. But now we will learn about conditional and iterating statements. Means the condition will be checked, and if the condition is true or false, then the program will flow in that manner. So Python provides the control structures to manage the order of the execution of the program, which is done by if-else statement, for, while, and the various jump statements like break and continue. There are three types of statements in Python. Empty statements. The first kind is empty statement. Empty statement means where the program does nothing but the flow passes without any error and the program will show no output. Pass statement. Second is simple statements. Simple statements are single line statements, or even if they are multi-line, they are not bothered about indentation. Simple statements. Here the example is num is input, enter your number. We can take another variable and we can put the variables and the numbers inside it. They are simple statements, whereas the third kind are compound statements. The compound statements have a syntax in which there is a header section followed by a colon sign, and the body must be indented with multiple simple or compound statements. The header starts with a keyword and will end with a colon. Syntax has to be kept in mind very carefully. The body contains many simple or compound statements. So there are three types of statements: empty statements, simple statements, and compound statements. Coming to the statement flow controls, in every programming language, the program executes in different manner that is called as flow of control. And they are of three types: sequential, selection, or iteration. As the name stands, sequential means step by step in a sequence, one after the other, the statement will get executed irrespective of the condition. Whereas in the selection statement, there is a decision making condition or a decision is taken. Likewise, to write a program to find the greater of any two number, we have to use selection or decision statements. The flow chart shows that when the two numbers are input, the condition is tested. This diamond-shaped box is testing the condition. If the condition is true, if A is greater than B, then the program will show the output for the true part of the block. True block will be executed. But if the condition is false, else block will be executed, meaning thereby the decision is taken. And then the program goes to stop and exit. Whereas in iteration means looping. In looping, the program will test for the condition and again the control will go to the condition in a cyclic manner until the condition turns false. It will go to the body of the loop again and again, counter, and will check for the condition. When the condition will turn false, the loop will terminate. So, in this flow of control, we will learn about selection statements and iterative statements. Before coming to the selection statements, let us discuss program logic development tool. A program logic development tool is also called as program development lifecycle. First of all, in the first step, the problem is identified. The program is identified. What kind of program it is? Is it a sequential? Is it a logical or an iterating program? Secondly, we analyze the data, the inputs and the outputs. Once we have analyzed what kind of program it is, what is the input, what should be the output, now we will write its algorithm. That is to write the program in a precise step-by-step manner, or we can draw its symbolic representation called the flowchart. When we have all these things, then we can write the program code. Since we know what should be the input, what output can be predicted, we have predicted it, we have assumed it, so now we will write the code. Writing the code meaning thereby writing the code using a specific programming language. In our case, it will be Python. Once the program is written, it is then tested and debugged. Because if a program is having any error, we will not reach to the desired output. So a program has to be debugged. Errors must be removed. Once it is error free, now the program will be used for live run, that is the execution, the implementation. After the implementation or the live run of the program comes the program maintenance, that is documentation. In order to enhance the program quality, we may use documentation, the comments, etc. So these steps should be followed one after the another in order to create a good program. Algorithm, as told earlier, is a set of rules or it is a process followed in a problem solving operations. That is called as algorithm. It is, for example, here I have taken an algorithm to add the two numbers. What we will do? We will take a first number, we will take another number, we will use the operator, plus we will add the number and store it in a third variable and then finally print the value. It means this is how step by step the program will be executed. So before writing the program, we can write a layout, that is the algorithm. Also the flow charts. They are the symbolic representation of an algorithm. And they tell us how the program is working or flowing. See here, step by step, they are showing, depicting here that how the program flows from top to bottom in this program. So the flowchart shows the steps in the form of various symbols or boxes and they are connected by the means of an arrow. So here is a flowchart to calculate simple interest. We'll start the program, input the three variable value, we'll process it, put the formula and calculate it, and then finally for the result we will print the resultant variable and the program goes to stop. And now we will learn how to write the programs. We have already learned how the normal program, the step-by-step programs are written. Here it is no logic is there, simply we are finding the simple interest. In next slide, we will see how to write the selection statements, how to make the use of selection statements. So again, selection statements are decision statements. There are different kinds of decision statements in Python, of which the first is if statement. This is the first kind of selection statement. The first kind of selection statement is if statement. If statement means it will test for the condition. If the condition is true, the statement next to the condition will be executed. The condition syntax here is if. If is a keyword, has to be written in lowercase, then the condition is given followed by colon sign and the statement. See the cursor here. If the condition is true, the control will flow to the body of the if and will print that particular statement. But what if the condition is false? If the condition is false, the control will get out of the body and exit, because here we have no choice, if or else. No choices here. Simply the things will be processed and output will be shown if the condition is true. So we also call it as simple if. In the program here, I have assigned a variable A as 40 and testing for the condition if A is 10. If A is 10, then the number is 10. Now, in this case, is my A 10 is equal to 10? Is it 10? No. A here is 40 and I am comparing this 40 with 10. Is the condition true? No, the condition is not true. So the program will it show the program? No, the program will exit without showing the output, because A initialized as 40 and being compared with 10, so A is not equals to 10 here. So simple if means if the condition is true, then only the program will show the output. Otherwise, the program counter will flow out of the program body and exit without showing any output. The second form of if statement is if else. It means it has two parts, if part and else part. In the program here, let's see in the program, if block and else block. See, indentation has to be kept in mind. If block gets executed when the condition is true and else block executes when the condition is false. It means in either of the case, we will get the output whether the condition is true or false. Why? Because here the control will flow to the if part when the condition is true. If it is not true, it means it is false. It will jump to the false part. In the syntax, we can see here that it has two parts. When the condition is true, which is executed? If block. If the condition is false, what is executed? Else block. So we say that in if else statement, there are two statements, and if the condition is true, then true block gets executed. If the condition is false, else block gets executed. We can take another example of finding the greatest of any two given numbers. Again, we will take the two variables here, A and B. We will check for the condition, and if the condition is true, the if block will be printed. If the condition is false, the else block gets executed. So here one very important thing to be kept in mind is that there is no condition specified with else statement. Why? Because if the condition is not true, then it is understood that it is false. So control will flow to the else part. So we do not have to write that another condition for else part. Third form of if else is if elif else statements. Now, when out of the multiple statements, it is required to select any single statement, one statement for processing on the basis of a condition if elif else statement is used. Means when multiple statements are there and of those multiple statements, one needs to be get executed, then we are using if elif else statement. Its syntax is if condition, then statement 1 means if the condition is, see the cursor here, if the condition is true, its supporting statement 1 will be executed. If it is not true, the control will flow to the next condition. If it is not true, then again the control will flow to the third condition. Again, if it is not true, it means it will go on up to the nth condition. Now, if none of the condition is true, then what? Then else part will be executed. So we call this else as default. Default means when all the conditions are false, then default part of the program gets executed. If, elif, else. Here is a program. We have taken A as 40. If A is 10, number is 10. Elif A is 10, number is 20. See, elif A is 10, number is 30. Now what? Else. So what was happening in my program here? Every time the condition was false. So what get printed? Not 10 or 20 or 30. So when did this else part execute? This executed when all the conditions were false. Had it been A as 10, suppose A is 10 now. So my first condition turns to be true. What will be executed? The statement next to it. Now the program will not flow to the next. Why? Because it has already got the true condition and will exit out of the body of the program. So this else part is executed when all the conditions are false, while if the condition is true, the statement is executed. If this is not true, it will come to the. It means again it is going step by step, but depending upon the condition, so it is called as conditional statement. Another important thing here is that elif takes a condition, else does not take a condition. See, else is not taking a condition, while elif has to take a condition. So we have learned till far, we have learned three types of if statements. Simple if else, third was if, elif, else. Now the fourth form is nested if else statement. Nesting means if within if. One if, then within that if there has to be another if, and so on. So nested if else statement allows you to check for multiple test expressions and execute different codes for more than two conditions. It means at a time we are checking for multiple expressions, means multiple conditions are tested, not a single condition. Why? Because within one condition there is lying another condition. That is called as nested if. In this program, I have taken a variable num and checking for if num is greater than 0. It means it is a positive value. This program is for testing whether the input number is 0, positive or negative. If num is 0, then it will print num is 0. If it is not, then it is positive. If it is not then 0, then it is negative or positive. So here, see the indentation matters a lot. If and this else is of outer if and this else is of inner if. The indent has to be kept in mind. We are entering a number. The number entered is 5. It will check here. Num is 5. 5 is greater than 0. Then coming to here. 5 is equal to 0. Is 5 is equals to 0? No. So program will come to which part? Else part and print the message the number is positive. So this is called as nested if when the program has if within if, it is called as nested if. It means when there are multiple test conditions, then we are using if within if. Another program here is we have taken here three variables and trying to find out the greatest among them. Now, when there are three variables A, B, C, A needs to be compared with B, A has to be compared with C, and third is B needs to be compared with C. So, see how many conditions are arising? Three different conditions. So, for three different conditions, we are using nested if. If A is greater than B and A is greater than C, then of all these, what is greater? A is greater. It will print the value of A. If it is not greater, then what is greater? C is greater. Now, what is left is, whose comparison is left? B is not compared with C. When B is compared with C, the B part is printed. If it is not greater, then it will go to the else part. So here is an output. We have entered the three numbers 2, 3, 4, and it will print the greater number. 4 is greater number. So nested if. Now we can test for by taking certain examples, and I have taken the examples, I'll show you the outputs as well. So input the year and check whether the year is leap year or not. Suddenly it comes into my mind that it is if, because if the input year, how the children at this level will identify the kind of the program which was told in the program development life cycle. As it is, next question is, find the largest among the two numbers. It means it stucks into my mind that yes, there should be if statement. Then next, largest among the three numbers, again if. When check for whether the number is even or odd, again if statement. So here are the programs. I have taken a program. Write a program to check for if the input year is a leap year or not. Leap year is when the given number is divisible by 4 or 2, modular divisor. If it is modular division is giving 0, then it is a leap year. If it is not, then it is not a leap year. We all must be knowing about the modular division, that this percentage sign is not finding the percentage, rather it is a modular operator which gives the remainder as the answer. When after dividing the number by 4, we are getting 0, the number is leap year. If it is not, then it is not a leap year. The program control will go into the else part only when the condition is not true. The next program example is, find the larger number among the three input numbers using the logical operators. Before learning all these programs, sequential selection, we must know the operators, and we have learned it in our prior chapters. Operators are the symbols. Now there are different kinds of operators. Here I am using logical operator, and or not are the three different logical operators. So finding the largest among the three numbers, and operator is used. See, this has reduced the program complexity as well, and also the length of the program, as we have seen in our previous case, finding the greatest of the three numbers. The same program can be used in this manner also, can be written in this way. If A is greater than B and A is greater than C, what is greater? A is greater. Else, elif B is greater than A and B is greater than C, then print B is greater, else C is greater. So we can also use the different logical operators to check for whether the number is odd or even. Any number modulus divided by 2, if it gives 0, it is an even number. If not, then it is an odd number. See children, we can also write this statement as, if num modular divided by 2 not equals to 0, not equals to, the exclamation mark is equal to 0, print it is odd, else print it is even. That depends upon the use of the operator. So this is all about the selection statements or the decision statements. Thank you and have a nice day.